This is AS Pure and Stats Paper 2, 2022. Find this. So you just increase the power by 1, and then divide by the new power, and then add a c because it's an indefinite integral. So it's 12 over 4, which is 3x to the power of 4 plus c. So it's this one. Cosine of theta minus 20 equals cosine of 60 degrees. Okay, so what you need to do for this is, what is cosine of 60? Well, cosine of 60 is a half, all right? And, well, we're saying that this here, this input equals this input. So we're saying that theta minus 20 degrees equals 60 degrees. All right, what other value is equal to 60 degrees with cosine? Well, 300 degrees. It's 360 minus this. So theta is 300 plus 20 degrees. So it's this one here. A curve has equation this, where k is a constant. Find d2y by dx2. So find the second derivative at this point. We've got this. I'm going to write it to the power of half because it's easier to differentiate that way. Multiply the power by the coefficient and then reduce the power by 1. So this is a half kx to the minus a half. Okay, and then just do the same thing again. So this is going to be minus a quarter kx to the minus 3 over 2. Because a half take away 1 is minus 3 over 2, obviously. And then substitute in when x equals 4. So you just put that in. You get this. So this is going to be minus k. Obviously, yeah. So you square root 4, which is 2. And then 2 to the power of 3 is 8, but it's a minus, so it's 1 over 8, so it's minus 1 over 32k. The equation, this has no real solution, so the discriminant is less than 0. Just plug in b, plug in a, and plug in c. B is 4, a is 9, c is p squared. You'll get this. Expand this, you'll get this. I'm going to multiply by 1 on both sides, but be careful, because when you do that, you're actually... Oh yes, first of all, divide by 4 here. When you multiply by 1 on both sides, the inequality actually changes sign, like flips sides. So it becomes like this. This is a difference of 2 squares. You get this. P equals 2/3, P equals minus 2/3. And then if you just imagine that you want to be greater than 0, so you want to be greater than 2/3 or less than minus 2/3. Kara's investigating the function. Statement 1. F of 3 equals 0. If you go ahead and just plug in x equals 3 into all of this, you will get 0. So just say true, because if you sub x equals 3 into f of x, you get 0. This shows that x plus 3 is a factor. That's incorrect, because x minus 3 would be the factor. So just say that false, because x plus 3 equals 0 would give that f of minus 3 equals 0, not f of 3. Fully factorize f of x. This was f of x. We said that f of 3 equals 0, which implies that x minus 3 is a factor. So x minus 3 multiplied by some quadratic gives you this. Okay, the only way to make an 2x cubed is to multiply this by that, and that gives us ax cubed. So a must equal 2. And then c must equal minus 15, because the only way to get the constant term at the end is to do minus 3c. So minus 3c equals 45, therefore c equals minus 15. And then b would equal minus 1, because the only way to get an x squared, the only way to get the x squared here is to do bx squared. So if we just look at the coefficients of x squared, we'll have b minus 6 equals minus 7. So b minus 6 equals minus 7. Add 6 to both sides. B equals minus 1. So you get that. And then this, you can factorize this out even more. Do not solve it. It's not equal to anything, so just leave it like that, and that's your answer. To find a dog's equivalent human age in years, multiply the natural logarithm of the dog's age in years by 16, then add 31. So 16 log 5 plus 31, and that's approximately equal to 57 if you put that into a calculator. A dog's equivalent age in human years is 40. Find the dog's actual age to the nearest month. Okay, so 16 log of x plus 31 equals 40. That's the human years. That's the dog age. We don't know what it is. Take away 31 and then divide by 16. You'll get 9 over 16. E to the power of this and then e to the power of that will cancel the natural log. So you just get x equals e to the power of 9 over 16. You want to multiply this by 12 because you want the months. And this is in years right now. So you have this, which is approximately 21 months. Explain why the behavior of the natural log for values close to 0 means that the formula given on the website cannot be true for very young dogs. It's because if you do the natural log of a number that's less than 1, so say the dog was like 0.6 years old, maybe it was like a few months old, it'd give you a negative result, and you can't have a negative age, obviously. You need to say the second part for the second mark. this is just literally a rationalizing question. So multiply by the conjugate, so it's 2 minus root n over 2 minus root n. This is 6 minus 5 root n minus plus n at the top, and then this is just 4 minus n. So you get this. I'm going to reorder it a little bit just to look like this, and then I'm going to split it down the middle like that, because they've actually written it in quite a weird way, where A equals this and B equals this, if you just have a look at that. Triangle ABC has sides of length m minus n, m and m plus n, where this, you really don't need to worry about this. This is just to make sure it's actually possible. Explain why angle A must be opposite the opposite side of length m plus n. Well, m plus n is going to be the largest length because you're not going to have any negative lengths, and you're not going to have where m or n are equal to 0. Therefore, m plus n is actually the largest length, and the largest angle is opposite the largest length. And the largest length is m plus n. Using the cosine rule, show that cosine A equals this. Okay, so if you draw the triangle, you say m plus n is here, m is here, and then m minus n is here. It doesn't matter, you can swap these two around, just as long as this is the largest angle. We'll call that A. Cosine rule is this, you should know this. Just rearrange it for cosine A, you'll get that. And then plug in where this is A, this is B, this is C. You get that. Just expand them out very carefully. M here, m squared here, cancel. This is 2mn minus 2mn, so it's 2 plus 2mn, so it's 4mn, and then this and that cancels. So you get that, and then what you can do is, you can cancel the 2's, but I don't think I've done that yet, I've just moved it up here. Then I've cancelled the 2's, I think. Oh no, I've multiplied the bottom one by -1, because here you can factor out an m to get that. I've already simplified it there. And then this, and then this, and that cancel to give you that. You're given that BC is the diameter. I've just said that. Let's say that BC is this, right? Okay. And if this is if there's a circle around this, and this is the diameter, then the lengths here, if it meets up at the circumference, this must be 90 degrees. Okay, so angle A is 90 degrees, and then you can use Pythagoras. So this squared plus this squared equals that squared. We know that m is 8, so just plug it in. Just be very careful here. You've got 128. You've got 64 out of 64, so you've got 128. Most of the other things cancel. You'll get 32 n equals 64, so n equals 2. Diagram below shows this and that. Write down the three inequalities which together describe the shaded region. I've written this here as x minus 6, x plus 2. You don't actually need to do that, but if you just imagine it, you want to be less than or equal to y, because I'm sure you'll be able to come up with this, but you just want to be less than y. Okay, I think it'd be best to work with the other ones first. So work with this line here, and then this line here, and then you should see that this should be less than or equal to y, just intuitively, hopefully. If you look at this line here, you're going to be under y. So for each given x value, you'd always want to be less than y. But then you've also got this line here, which is y equals 0. Okay, and you want to be greater or equal, greater than or equal to y equal to that line there. Okay, and then yeah, that's fine. That's done. Write down the coordinates of A, B, and C. Well, we know what A and B are because we calculated this when we factorized this quadratic. So this x coordinate is 6, this is -2. We have this other line here, y equals x plus 2. To find this, what you could do is you could just solve it simultaneously. It's the only way to actually do it, because if you imagine a simultaneous equation is just the intersection between two curves. But first of all, let's just set that equal to 0. Okay, and then we'll say that x equals 6, x equals -2. It's obviously on the where y equals 0, so the coordinates are this. Okay, and then we'll solve this simultaneously with that to get that. Well, this with that actually to get that. Just expand, and then just be careful when you're tidying it up. This factorizes into that. X equals -2. We already have that as being here, so we want x equals 7. These are the solution. If you plug it back into here, 7 plus 2 is 9, so y equals 9. So C is 7, 9. Find the exact area of the shaded region. Okay, so what we're going to do is we're going to find the area of this big triangle here, AC, and then down to like whatever this point here is, okay? And then we'll take away, because we counted this extra area here, we'll take away that area by integrating. Okay, this is the 0.79. This has x coordinate -2, and then this has x coordinate 6 because we calculated that last time. So if we do that, half base from -2 to 9 times by height, which is 9, so half of 9 times 9 equals 81/2. So that's the overestimated area. Okay, and then if we integrate between here and where x equals 6 and x equals 7 is, to get rid of this smaller area here, then we can subtract that from this to get this exact shaded region. So yeah, you do this. This is just increasing the power by 1 and then dividing by the new power. You could add a plus c, it doesn't really matter. You're going to cancel it out because it's a definite integral. So this would be a third x cubed minus 2x squared minus 12x plus c to get that. From 6 to 7, so you've got this. Plug in 7 and then plug in 6, subtract them from each other, put it into your calculator, you got 13/3. Okay, so this area here is 13/3, and we overcounted the area, so we do 81/2, take away 13/3, which is 217/6. Find the value of A. Okay, so a bottle of water has a temperature of 6 degrees Celsius when it's removed from the refrigerator. It's placed in a room where the temperature is 20. 10 minutes later, the temperature is 12. Okay, so at time where t is 0, okay, so after 0 minutes, so like we're saying 0 minutes and 0 seconds, the temperature should still be 6. Okay, so we plug in t equals 0 and then 6 for t. E to the 1 is just 1. So you got that, and then a equals 14 if you just rearrange that. Calculate the value of k, giving your answer to 2 significant figures. So we have this with the value of a that we just calculated. Okay, at time t equals 10 and then temperature equals 12, plug it in, subtract 20 from both sides, and then multiply each one by -1 to get this. Divide by 14. This is 4/7 if you care about simplification. Doesn't really matter. Take the natural log of this side and then the natural log of this side, because then it'll cancel with the e here to get this equals -10k, and then divide by -10, and then just put that into your calculator. You'll get k is this, which is this, to 2 significant figures. Using this model, estimate how long it takes the water to reach a temperature of 18 degrees Celsius. Okay, so with the values that we calculated, use the rounded one, because it says with the values that we calculated, don't use the exact one, just use the rounded one. When t equals 18, so it's literally the same thing. Take away 20, so you get -2, and it equals -14e to this, and then multiply by -1 on each side. Divide by 14, 1/7 equals this, natural log of both sides. Divide by -0.056 to get t is this, which is around 35 minutes. You can say 35 minutes and you'd get the answer, right? Explain why the model may not be appropriate to predict the temperature of the water after 3 hours. The room temperature could change. Somebody could drink the water. You could, lots of things could happen. And also, after 3 hours, you'd expect the water to reach room temperature. But if you plug it into the equation, you won't actually reach room temperature. You'll be very close to it. You'll be like 0.0002 something off, even though it should be just room temperature. Which of the terms best describes the distribution represented by the box plot shown in figure 1? Okay, this is the stats part. It's negatively skewed because the longer tail side, if the longer tail side is on the left, then it's negatively skewed. If it's on the right, then it's positively skewed, and it's obviously not symmetric or even. Shirley organised an activity weekend for 15 groups of 10 people. She decided to collect a sample to obtain feedback about the weekend. She selects 2 groups at random. Okay, so she's got like a group of people, and then she selected clusters from it. Hopefully that just, if I'm sure you'd know this. This is just, you learn this at the beginning of the course, so I don't think you'd have a problem with this being a cluster sampling method. Okay, so we've got NOx emissions, and we're saying that we want to find the mean and standard deviation of the 2016 sample data. and we want to give our answers to 3 decimal places. Okay, so to find the mean, just sum all of these together and then divide by 12. It tells us there's 12. But obviously 2 times 6 is 12. I'm not going to do that. I've just put that in. I think I just copied this from the mark scheme, but if you sum all these together, you'll get 0.312. That gives you 0.026. Okay, and then to calculate standard deviation, this is a formula that you're given. Where 0.026, this is x minus x bar, where x bar is just the mean. Okay, and then x is just each value, and then you sum each of them. Okay, so say if you sum in all this, you'd plug in x equals 0.005. Okay, and then you'd add that to when x equals 0.047 to that, and then you just keep on going until you finish. I think your calculator can do that for you, but you'd get 0.021 to 2 decimal places. Oh no, oh yeah, sorry, to 3 decimal places. Yeah. City claims these examples show that on average, NOx emissions across all makes of car in all areas of the UK have fallen by over 75% between 2002 and 2016. Okay, well, that's just clearly not true because... Oh, no, never mind. Okay. Yeah, I thought it was onto the... This can't be true, and I'll get to that later. That's actually the next part of the question. We're saying that the mean is 0.026, which we've already calculated. Okay, and we're looking for the percentage change from here to here. Use the equation, or you could just say let x be some random multiplier. So you do 0.122x equals this, and then rearrange for x. And then because x will be a multiplier, just convert that into a percentage. You'll get the same thing as 78.8%, which is greater than 75%. You need to show this part here to get the extra mark, the second mark. Make 2 comments on the validity of City's claim. First of all, there are a couple things. The sample size is not big enough. I mean, you took 12 samples for that entire year. It's not large enough to make comments about the entire nation. Okay, and second of all, it can have been all makes of car because there'll have been more makes of car created in 2016, which might emit different amounts or concentrations of NOx gases. So you can't possibly account for that back then. For any 4 randomly selected visits to the gym, find the probability that Yingtai chose at least 1 banana. Okay, so the probability of choosing at least 1 banana is the probability of not choosing a banana. Okay, so it's just the probability of not choosing a banana. The probability of not choosing a banana every single time is just 0.45 add 0.2, which is 0.65 to the power of 4. Probability of not choosing the banana 4 times in a row is that. 1 minus that is at least choosing it once. Okay, the same item each time. Well, to get the probability of getting the same item each time, you're getting this 4 times in a row, or this 4 times in a row, or this 4 times in a row. You sum all those together to get that. You get an apple twice and a cake twice. Okay, so you'd get 0.2 twice, so 0.2 multiplied by 0.2. Add 0.45 multiplied by 0.45, which is this, and you get that. But that's not the complete and final answer because there are a few ways to arrange this. First of all, you could get an apple cake, which is what I've said here, or you could actually get an apple cake, or you could get a cake apple, or a cake apple. There are a few ways to do this, but you can just use the choose function. So you have 4 possible days, and you're choosing 2 different things from them. So how many ways can you arrange 2? So it's just 4 choose 2, and if you put that in, you can just put this into your calculator. It gives you 6. Factorial just means, I'm sure you know what factorial is because you've done binomial expansion. You get 6. So there's 6 ways to arrange this to either get an apple cake, or apple cake. I mean, so you do 6 multiplied by that to get this, and that's your answer. The discrete random variable x is modeled by this probability distribution. Okay, state in terms of k the probability that x equals 3. Okay, so when x equals 3, we're going to be looking at this point here. So you just substitute in little x equals 3 to here. X squared is 3 squared is 9, so you get 9k. Given that the probability that x is larger than or equal to 3 equals 3 times the probability that it's less than or equal to that x is less than or equal to 2. find the exact values of k and the exact value of c. Okay, so first of all, probabilities will always add up to 1. So if for every value of x, 1, 2, 3, 4, 5, 6, 7, obviously after 4 it'll just be 0, so you don't even need to account for it. But plug in x equals 1, 2, 3, and 4 for each of these, and then add them all together, and then just collect like terms. Make it equal to 1 because it's probability. Okay, now we're saying that the probability that it's greater, that x is greater or equal to 3. So we're looking at this section here, where it's when x equals 3 and when x equals 4. So that's 9k, add 16k, so that's 25k, equals 3 times, and then it's 1c plus 2c, equals 3 times 3c. Okay, this is 9c, obviously. This and that, you can solve them simultaneously. These 25k's match up, so this is 3c plus 9c equals 1. 12c equals 1, so c equals a 12. Plug this into there, you'll get that, divide by 25, and you get this for k. It's believed that a coin is biased, so the probability of obtaining a head when the coin is tossed is 0.7. Assume that the probability is 0.7. Find the probability of getting exactly 6 heads from 7 tosses of the coin. Probability of heads is 0.7. Probability of tails is 0.3 because it's 1 minus 0.7. So you could get heads 6 times in a row and then get tails once. Okay, and you'll get this. But obviously there are a few ways to arrange this. This is 7 choose 6. Okay, because there are 7 different if you imagine the tree diagram, there'll be 7 branches. Okay, imagine it as like being split up into columns. You'll have 7 columns. Okay, so how many ways can you rearrange those 7 columns? Where you'd either get a head, 6 heads and then 1 tail, or you might get 5 heads and then 1 tail and then another head. You know, to arrange all of those to get all the possible combinations, you do 7 choose 6. Okay, which is 7. So you do 7 multiplied by that, which is this. Find the mean number of heads obtained from 7 tosses of the coin. You get given this in a formula booklet. It says you just multiply them together basically. You get 7 times 0.7, which is 0.49. But intuitively what this means is that the mean tells us what the likelihood of obtaining that many. It's basically how many heads you'd get. Okay, so we'd get 0.7 heads from 1 tail, from 1 toss. Okay, from 2 tosses we'd get 0.7, add 0.7, so we'd have 1.4 tails. Okay, if we do it 7 times though, it's just 7 times 0.7, so we'd expect to get 0.49 heads, sorry, not tails. And oh yeah, sorry, I did not mean to say 1.4 here. I meant to say 0.7 times by 2. Harry believes that the probability of obtaining a head for this coin is actually greater than 0.7. To test this belief, he tosses a coin 35 times and obtains 28 heads. Carry out a hypothesis test at the 10% significant level to investigate Harry's belief. Okay, so the significance level is 10%, so we can just say that alpha equals 0.1. Alpha just means the significance level. If you're unsure what this actually means, it's just basically, you know, it's how eager Harry is to actually reject the null hypothesis, or what the main belief is, which is that it's just 0.7. Okay, so we're saying that the null hypothesis is 0.7, and then that the alternative hypothesis is, which is what Harry believes, is that it's greater than 0.7. Okay, so under the null hypothesis, we're going to assume that x is distributed as this. So over 35 tosses, this and then the probability of getting a successful head is 0.7. Okay, and then we're saying that the probability where x is larger than or equal to 28, so it's the probability of getting 28 heads or more, and the reason why it's inclusive is because we're testing for extreme values that are like close, that are very close, is you know, because basically the reason why we have this equal sign here, it actually confused me for quite a while before I, you know, researched it. It was because let's say that if you drew the curve, okay, I actually pulled it up on Python. But say if you just ask ChatGPT and you put this question in and you ask it to draw you a graph for it, you'll see it'll pull up Plotlib, and it'll show you that at 28, when x equals 28, there'll be bars, okay, and that full bar is shaded in all the way to the right, because this is actually a one-tail test, and you ignore the left part, the left side, okay, and you'll see that it's even included to the left of it by a small bit, so it's inclusive here, okay. You could just put this into your calculator, but if you want to know how you actually calculate this, you do this. So it's you're starting at x equals 28 and you're going up to 35 because it's greater than 28 but inclusive, okay. If you calculate that, you'll get 0.13265, and then you can just round this to get 0.133. You are allowed to round it here. You get this in the maximum, that's fine, okay. And we compare this to the significance level, and because it's greater than the significance level, we accept the null hypothesis and we reject the alternative one, because there's insufficient evidence to say that it actually is greater than 0.7. This step here that I just did like this, you might not want to do it like this because it just looks like a lot. What you could do is that this equals 1 minus the probability of where x is less than or equal to 27. Just maybe sit there for a few seconds and think about that. Hopefully that makes sense. Because in your calculator it wants it in this form. Anyways, that's everything. Thank you for watching.